Okay, solve a differential equation now. A differential equation is just, it'd be an equation that involves y and the derivatives of y. So you're going to see y's and x's in these, and you'll usually see dy's, dx's also. And these model different situations, real or imagined, and we can solve them by one technique. There are many techniques, but this technique is going to be called separation of variables. And essentially means that you will separate the y's onto one side and the x's onto the other side. Whether they be y's, dy's, x's, dx's, whatever. If we can separate them, then we can use this technique. So, or at least we can try to use it. So here's the first example here. And let's see. Okay. So it says find a particular solution as opposed to a family of solutions. See, there are families and then there are particular solutions. Okay, so here's our differential equation. F prime of s, f assuming it's a function of s, and it's subject to this initial condition. So what we see here is that we have f prime of s, 6s minus 8s cubed. So the left side is a function. It's your y in a sense. And it's a function of s. It has to be a derivative. So in other words, and the right side is all s's. So what we'll do is this: we'll take the antiderivative with respect to s of both sides. So this is a legitimate step that will get us to all solutions. Occasionally, it leads to extraneous solutions, but we're not going to worry about that here. Okay, so now on the left side, we know it's just f of s, and we won't add a constant in there. Since there'll be a constant on both sides here, we'll just leave a constant on the right side to encompass both constants. So this left side would be f of s because f of s is the antiderivative of f prime. And over here now I want the integral of these two terms. So this would be 6s squared over 2 minus 8s to the fourth over 4. That's the power rule. And this will add a constant in here, c. Okay, so we can simplify that a little bit. So here's my function, and this is a family of solutions that, as you can see, all have the same shape, except that they're moved up or down in the xy plane by this amount, shifted up or down, whatever c happens to be. So we want the one that fits this situation. So you'll take and you'll put in f of 2, which is 3 times 2 squared minus 2 times 2 to the fourth, plus a c, and we know that that's equal to 3. That gives us a way to find c. So let's see, all we have to do is 3 times 4 is 12 minus 32, and we'll say plus c equals 3. So I don't need this extra equal sign here. All right, so now, what is this? Negative 20 plus c equals 3. So c must equal 23. That means that finally, back down here, the function that satisfies this differential equation looks like this. This is our solution to the differential equation. Okay,